Hi everyone, welcome back to my channel. Today we're gonna solve longest substring without repeating characters in LeetCode. So I think this is really great question because the question itself is really simple. It can be solved with multiple different ways, and we can actually use multiple data structures to solve this problem. So here we go. So we have a string s, and we have to find the length of the longest substring without repeating characters. Let's just look at example. We have string abc, abc, bb, and then the answer is 3 because abc has a length of 3. When you're thinking about this question, it doesn't really need to be abc. It can be longest substring is bca or cab. But in this case, you have to remember that order of these characters don't actually really matter. Also, let's look at example 2. We have s, b, 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 b. The answer is 1 because b is the longest substring. And then we have this p, w, w, k, e, w. And we have output 3 because w, k, e is the longest substring. All right, let's try to solve the problem. I'm going to introduce 3 different ways. In each way, I'm going to introduce one way and then code, one way and then code, and one way and then code. So it's going to be just back and forth, okay? So, all right. Let's talk about naive solution that I thought about. Let's say we have a string, input string as A, B, A, C, D. The one solution that I thought about is having 2 pointer, left pointer and right pointer, starting from this 0th position. So the one way I thought about is having 2 pointers and data structure called set. Whenever we move the right pointer, we are going to see if A exists in our set, and then the next we are going to see if B exists in our set. At this point, we are going to have A in our set. Okay, so next iteration, we're going to move the right pointer to B here, and then we're going to add B, and then we're going to hit A here, and we look up if A exists in our set. A exists, then this is naive solution. Then we move the right pointer by 1. And then we move our left pointer to the left pointer's position. And then we actually have new set, new empty set, and then start from the beginning. So this way, what we end up doing is that, so basically what we are doing here is that, let's say we have string, some random string like this. We're going to check this guy, and this guy, this guy, this guy like this. All right, this time I'm going to introduce sliding window solution. All right, so intuition is actually pretty similar. So let's say that you have a string C1, C2, O, C3, C4, C5, O, C6, C7, C8, and so on. The approach is very similar. We are going to have left pointer and then right pointer starting from the 0. And then we are going to have set data structure. And then we're going to keep track of maximum length to return the answer, okay? So, all right, let's do this. First, the right pointer is pointing to the C1. The C1 exists in our set, okay? We're gonna add it. We move the right pointer to the right. Does C2 exist in our set? No, so we're gonna add C2, okay? The same way, we're gonna add O, C3, we're gonna add C3. All right, while we are adding these character in our set, while we are moving this right pointer and adding these characters into set, we are going to keep track of the max length. It's going to be max of max length itself, max length of substring that we found so far, and then the size of the set. let's get back to the iteration. We have this C3, okay, move the pointer, C4, C5, okay. And then we are gonna hit this O. When we hit this O, we are gonna look up the set if the set contains this O. And O is here. So in this case, what we're gonna do is actually pretty interesting. What we're gonna do is remove this C1 character out of the set. It's because, okay, we already keeping track of the substring of C1 to C5 because as soon as we are adding this element, we will keep track of the maximum length. What we want is actually the substring from the C3 to here, right? So what we're going to do is we're going to remove one by one. Let's try to simulate. We removed it, and then after we remove the C1, and then we're going to move the left pointer to C2. And then check, the right pointer is here. O still exists? Yes, O exists in our data structure, in our set. So we take it out, all right? And then we move the left pointer to O again. And then check, does O exist? Does O exist? The right pointer is pointing to O. Does O exist? We're going to take out the character that left pointer is pointing to. So that's happened to be O. So we're going to take that out. And then after that, we're going to move the left pointer. All right. After we remove the right pointer, we're going to check the we're going to see if the character that is right pointer is pointing to still exist. Does O exist? No. We just took it out and moved the left pointer to the C3. And in this case, we're going to put O back in. So you see the intuition here. Now in our set, there's a C3, C4, C5, O. So it is now representing this, right? That way we can actually calculate the possible length of this substring. So this is how you do it. And this solution is going to take, in worst case scenario, O of 2n. Because in worst case scenario, the left pointer have to point every single character here. Also, right pointer have to go through every single character in this string. So it might take a worst case scenario, big O of 2n, but this boils down to big O of n anyway. What is space complexity of this algorithm? It's going to be O of k. K as the length of max length, which is the longest substring's length. Let's try to code the sliding window. So actually we're gonna what do we need? What kind of data structure we need? We need scene character. This is going to be set. And then we have left pointer and then right pointer. Start from 0. And then what do we need? What else do we need? Oh yeah, we need to keep track of max length. Okay, and it starts from 0. So in this case, we need while loop. We're going to have while loop. Let's say right pointer is until smaller to length of string. So in this while loop, there are two cases. The right pointer character is in the set or is not in the set. There are two cases. So we're going to have this if and else statement. If srp in scene char, then do something. We're going to have else statement. When the right pointer character exists in our set, we're going to remove the left pointer character. So we do this here. So scene chars remove the character of left pointer. And then we move left pointer by 1. Okay? When character is not found in set, we keep track of max length. Is max length itself and the size of the set here. Okay, we're gonna find the max length, and then we're going to add the character in our set. So scene chars add s right pointer, and then we move the right pointer, and then we return max length. Hopefully it works. Oh, it didn't work. Why it didn't work? All right, I'm in trouble. RP length. So actually, you have to add the character before calculating this max length. So in this time it's gonna work. All right, it worked. Let's try to optimize sliding window. Let's say we have C1, C2, O, C3, C4, O, C5, and so on. Okay, Cn. So for the sliding window, when the right pointer was here, our left pointer was just increasing one by one until we hit this O, and then we take out this O, we add this O back in our set. Instead of moving the left pointer one by one, can we actually do better? When the right pointer hit this O, can we actually magically move the left pointer to here? We can if you use hash map. Hash map is going to have char index pair. So when we hit this O, we look up the hash map if O exists in our hash map. O exists, and then we're gonna just move this left pointer to this is going to be something like, okay, let this M be a hash map, and then if we just do O plus 1 left pointer, then we can move this left pointer to C3 here. But in this case, we have to be a little bit careful. One thing that you have to do something like this. The character that you're looping through is right pointer. At the end of this iteration, you always have to update this character index pair again. So you can actually use the right index at the end. And also, one thing that you have to keep in mind is that from the sliding window, we calculated the max length, the answer, the return value of the function, by keeping track of max length so far and the size of the set. But in this case, the set, in this case, the hash map is going to contain every single characters. So in this case, you have to keep track of the maximum value of this range. You can do that by max length is max of max length compare right pointer minus left pointer plus 1. So this is actually the range of the substring, and then you keep track of the maximum of that. So this is going to be answer. All right, so let's talk about what's the time complexity. What's the time complexity of this optimized sliding window? So it's just gonna be take n time, because we're iterating all of these characters only once. And space complexity is going to be something like, in worst case scenario, it's gonna be O of n. Normal scenario is gonna be take O of k as the number of unique characters in the string. Let's try to code this solution. So this time let's solve optimized sliding window. We need a hash map. Python hash map is dictionary. We're gonna have char index pairs, and then we need left pointer and right pointer, and I'm gonna give them 0, and we're gonna have keep track of answer max length start from 0, and in this case we're gonna have one loop for character and character. Oh, okay, wait. So actually I don't need this right pointer here. For C and right pointer in enumerate string, because we are iterating string once. That's why right pointer can be here. All right. So let's see if C in char index pairs. If C is in the char index pair, we're gonna move the left pointer. Char index pairs of C plus 1. If the character doesn't exist in the hash map, we are going to keep track of the maximum value. Max length equals to max length itself, and right pointer minus left pointer plus 1 here. And then at the end of the for loop, we would have to update index pairs. C equals to right pointer. And then we have to return max length. Okay, I got the error. Oh yeah, it should be right pointer and C here. Yeah, pointer comes first. Oh, all right. So I got the error is because there's an important point here. So in this case, there should be one more condition, which is left pointer. When we are moving the left pointer, it should be smaller or equal to char index pairs C. So I need this is because there is some kind of situation like this. A, B, B, C, A. Let's say you have this kind of condition. When the right pointer is pointing this B, because of this condition, because of this statement, we already moved the right pointer here. We already moved the right pointer, we already moved the left pointer here. And then when you hit this A, the right pointer hit this A, because you're actually already at the end of the string, you want to count BCA, right? So A is, you don't need to move the pointer to B again. So that's why the left pointer should always be smaller or equal in order to have the right optimized solution. Let's try to run this. Okay, it works. All right, so this is the end of the video. If you think it was helpful, please hit the like button. That's gonna really motivate me to make more videos like this. I run small channel right now, so if you subscribe and like, that's gonna really give me that's gonna really make me happy and give me motivation. Yeah, just hit the like button and subscribe this channel. Yep. All right, so thank you so much, and see you again in the next video. Thank you.